In this video, we will be creating a model from GIS data and afterwards assign nodal demands based off of a property layout with known land uses. The first step is to know what projection our data is in, because we need to create a model with the same projection system. We can inspect this by going to the Projections tab and seeing what our projection system is. We can now create a model by going to Create Model New, assign a name. After creating the model, we can import the GIS data into the model. We're going to Manage Models, Merge into Model, Import from GIS. Now under the Warp Pipe tab, select our pipe links. A field mapping grid will be created where you can supply the model field in the to section for the source field. In this case, we select year for installation year, nominal diameter for the nom diam, and pipe status for the status. When clicking OK, the data will be imported. We can see that we have pipe data that has been imported and nodes have automatically been created at link endpoints. If we inspect the data, we can see that the material, nominal diameter, year, and status information has been copied. However, at this stage, the diameter field for all pipes will be 100 because we did not supply an analysis diameter. In this case, the default value of 100 has been applied. For this example, I will simply copy the nominal diameter to the diameter field. And you can see that the theme display has been updated to reflect these pipe sizes. The next step is to import our pump data. Again, going to Import from GIS, selecting the Pump tab, then Pump Links. In this case, we will not be importing the 8 points of the curve. That will be done afterwards into a curve table that controls curves. For this field, we will choose the Pump Station Operation Standby field, selecting OK. We can go to our pump table to inspect the information, selecting them and zooming to selection. In this case, we can see that our standby pump is the lower one, so we can turn this one off for normal operation, while the operational pump will be active. As default, 3-point curves can be applied in the pump table itself. With additional points, you need to create a curve. At this point, there are no curves active, and 0 not used will be displayed in the drop-down for curve selection. To create a curve, go to Model Data, Model Tables, Curve. In this case, we will add a pump curve, supply a pump curve number, which is an integer value, and then we can supply a description for our drop-down to easily find the correct curve. In this case, I'm going to call it the 8-point curve. For a pump type curve, we have X and Y values of flow and head, which we can extract from our source data. We can simply copy and then paste. In this case, both the operational and standby pump uses the same curve, so we can apply these to both pumps. By now going to the drop-down curve, our new curve is available, and we can set the curve as such. After the curve has been applied, we can also view the pump graph curve that has now been selected. The next step is to import our valve data, flow control valve. We're going to the Valve tab, selecting Valve Links. In this case, then we need to have set the setting to our valve setting field, status to valve status, and the type to link type. On importing, again, we can inspect the data, selecting. We can move to the current selection, active from the grid, and we can see that our data has been imported. The final step for a network hydraulic analysis model to be built, you require reservoirs or tanks. This we have available from our reservoirs shapefile information. In this case, we already have node position from the link endpoints, so now we can simply convert these nodes to a tank type. You will get a notification that fields that do not match will be lost, which is okay in this occasion. We click yes. Now we have a tank type. We can also do this for multiple node selections, as I will show now. Just making sure we select the model entity, going to the selected nodes and convert these to GL tanks. Okay. In this case, we do know that we have just select this, a external bulk connection. This will act as a reservoir. However, we do have different node types for theming preferences, so we are going to note this one as a bulk connection. To get the data of the reservoirs into the actual tank element, I'm going to use spatial correlation. As the points are at the exact location, we can use a very small distance for the correlation. So I will go to GIS Tools, Spatial Correlation, and then from our reservoir source data, I want to transfer the ground elevation information to my model tank data, and we are going to copy this to the ground elevation field using a very small distance. You can see that all three features have been matched. I can launch the previous function again by hitting the Enter key. This time I'm going to use the water level field and transfer this to our water level field. Again, using distance of 1 meter. Inspecting the tank data, we can see that the elevation and water level information has been copied over. Now that we have imported our model topology, if we inspect the node table, we will see that we do not have any elevations, as these were created while importing the pipe data. So from known DTM data, we can update the nodes elements, loading in DTM of the specific area. We can always confirm that we have coverage by just quickly generating contours and confirming that the information we have is covering our model. Next, we can update model elevations. In this case, I'm going to update nodes only because we have known data for the. We will now see that there is elevation data that was filled into the node table. The next step is to assign nodal demands, and we will be using the property shapefile that has land uses and assigning theoretical demands so that we can have a spatial distribution of demand on the model. So opening up, you can see we have different land uses. I'm going to select equal, and on selected, I'm going to assume a demand of 0 for open space. For residential, we will be applying a unit water demand of 0.85 and assuming all residential stands are using the same value, 0.85 kiloliters per day. We can also use the filtering capabilities to select. So for business, I want to apply a bit more of an advanced demand. And we can do this by executing a Lua script, either by going to the edit menu, execute Lua script, or hitting the equals key. Here we can enter a Lua script to fill each of the records. If you have saved a script, you can load it from our load script location. In this case, I've saved a script. All I'm doing here is applying based on the hectare, which is the area divided by 10,000, and applying a 40 kiloliters per hectare for everything smaller than a 0.2 hectares, and then stepping with a reduced increase as the size of the stand increases. Running the Lua script, we can see that we now have a demand. Now we have, for each stand, we have a demand that we want to correlate to our model. So we need to assign which node each stand is contributing to. Again, we can run the spatial correlation function. In this case, we are taking information from our model and using the node code, which is the unique identifier, copying this to our property into our node field. And in this case, we want to use a large distance to ensure we have full coverage. So we can see that all the items have been matched. Now we can see to which node each stand will be contributing. However, if we look in the information, we have multiple node information. So an easy way to transfer this data is by executing a Lua script, so we can summarize the data. Here we have a pre-set up script to select the node field and also the sum of the demand field from our properties layer, which can be selected from the insert table. And then we're grouping this by node so that we have a summary. When we click the Run button, we'll be prompted to enter a name. And we call this consumption summary. On entering the data, here we can see our new table that's been created. For each of the node numbers, we have the sum of the demands that it contributes to. We can also confirm if there are any duplicates, which there should not be, by selecting all duplicates from the node field. You can see that we have no duplicates. The next step is now to transfer this summated demand data into our model. At this moment, our data is in kiloliters per day, so we will be using one of the demand scenario fields in the node data. For this information, I'm going to use our match and lookup functionality, using the single one because you're only transferring a single data. So the from table will be our newly created consumption summary table, matching on node and copying our demand data. And we want to transfer this to the node table, matching on node code. And we are going to transfer this to the demand scenario 1 field. If you wanted to create a new field in the model, you can tick the create field checkbox, and the same field name will be created in the model table, and then the data will be copied. So after running the data, if we now inspect our node table, we can see that we have ADD or demand scenario 1 information applied. However, the output field is still empty. So here we can once again run a Lua script. In this case, we can say output equals our demand scenario 1, and then from kiloliters to liters per second, and then we apply a peak factor in this example of 2.5. We have now calculated the outputs, and our model is ready to be analyzed. Just going to switch off all the initial information. So in this case, we can run balancing our model, and then through the theming, we can view the results. So there we have flow rates. We also have demand head as an average on the links. We can view all the results tables, all the result fields. And in this way, quickly from a model to a simulation is achieved. As an additional point, as stated earlier, we have information that is not necessarily linked to the model for simulation. However, it does contain network assets. In this case, we can import the data into our model. The appurtenances table has a symbol type field controlling the type and does a straight copy from the source table to the model table. So the type, we can either change this field name to symbol type and it will automatically pick up the correct information, or we can afterwards use a spatial correlation. For this example, I'm going to change it to the same field name of symbol type, and then I'm going to use manage models, manage appurtenances, import appurtenances, and use my valve hydrant meters layer. It will also ask me if I want to copy data from my links. So if you have any memo table information that you've additionally applied to your pipes, which the appurtenances will be inserted onto, that data will be copied. Switching off this information, if we now view in, we can see that we have these valve and hydrant information. Especially the valve locations are very helpful if you want to know which pipes you can actually close running certain information, certain simulations. That concludes the video for a quick creation from GIS to the point of simulation. Thank you.